In this video, we'll discuss about economic operation of power system. In that, first discuss about optimum operation of generators on bus bar. In power system, the total operating cost that includes fuel cost, cost of transmission loss, labor and maintenance cost. Actually, the fuel cost is considered for thermal and nuclear station, but it is not applicable for hydropower plant. Here, the cost of generation depending on operating constraints. There are two constraints are there. One is equality constraint, another one is inequality constraints. Equality constraints that includes power balance equation, that is generation equal to demand plus loss. So this is the formula for real power and this is the formula for reactive power. Next one is inequality constraints. Under inequality constraints, there are lot of constraints are there. First, we discuss about generator constraints. Here, generator constraints that will include here loading should be within the specified limit, and then real power and reactive power that should be within minimum value and maximum value. Second one is voltage constraints. Voltage and angle should be within the limit. And third one is running space capacity constraints. Here the total generation that is G should be greater than specified value plus spinning reserve value. And next one is transformer tap setting. Here the transformer for auto transformer, the tap setting value T should be between 0 and 1, and for two winding transformers the tap setting is between 0 is less than or equal to T, less than or equal to N, and for phase shifting transformer the reactive part should be within the limit, that is minimum and maximum value. Next constraint is transmission line constraint. Here the real power and reactive power flow is limited by thermal capacity of the system. Cp should be less than or equal to Cp max, where Cp max is maximum loading capacity. Next one is network security. If there is no outages in the system, then all constraints must be satisfied. Suppose if there is any outage, that is fault is there, then constraints may not be satisfied. Okay, next we discuss about input and output characteristics of the generating unit. Here the graph, it is drawn between operating cost of the fuel and output power. Here what about if output power is increasing, obviously operating cost is what it is increasing. Okay, here F of Pj is nothing but fuel input rate. C of Pj is what is the cost of the fuel. Next one is heat rate curve. Here H of Pj is the heat rate in mega kilocalorie per megawatt hour, which is the heat energy obtained by the combustion of fuel in mega kilocalorie needed to generate 1 unit of electrical energy. So the graph shows the relation between the heat rate and the output part. Next, the heat rate, it is defined as input in rupees per hour to the ratio of input in rupees per hour to the output in megawatt. Next one is incremental heat rate. It is the ratio of change in the input to the corresponding change in the output of the operating point. Incremental heat rate is nothing but delta input divided by delta output. Next one is the generating unit efficiency. It is defined as the ratio of electric energy output generated to fuel energy input. And next one is incremental efficiency. It is defined as the ratio of delta P, that is the incremental fuel rate to the delta F value. And next one is fuel energy input. fuel energy input is given by the formula. It is H of Pj into Pj, where H of Pj is nothing but what is the heat rate. Next one is the cost function. Cost function C of Pj, we know it is nothing but K into F of Pga, where K is the cost of the fuel in rupees per mega kilocalorie per hour. And then we know what is the F of Pj value. F of Pj is nothing but what? Pga into H of Pj. H of Pj is nothing but what is the heat rate. And we all know about heat rate is given by the formula C divided by Pga plus Bi plus A of Pga. And then here A, B, C are cost coefficients. So F of Pj is nothing but it is P of Pga into H of Pga. So we are getting as A into Pj square plus B into Pj plus C. And then fuel cost equation C of Pj is nothing but what? It is K of Pk into Pga. So this is the formula to compute the fuel cost. Next one is the incremental cost curve of received power. For thermal power plant, the fuel cost is main operating cost, and it is accounts for 60 to 70% of the total operating cost. So here some of the assumptions are: first one is input output curves are continuous. The first derivative of input output curves are continuous, and incremental rate increases with the increases in output. So we know what is C of Pj. It is nothing but A into Pj square plus B into Pj plus C of Pj. So incremental means you have to differentiate this equation with respect to Pga. We are getting as if you are differentiating this equation with respect to Pga, we are getting as 2 into, if you are differentiating now, you are getting as 2 into A, 2A into Pja plus B. And then incremental cost is denoted as lambda. IC is nothing but what is the incremental cost. So the equation is 2 into A into Bi plus 2A into Pga plus Bi. And this is the curve shows the incremental fuel cost and output power. Okay. Next one is the coordination equation without loss. You consider the two bus system. PG1 and PG2 are the what about generation at bus number 1 and 2, and PD1 and PD2 are demand at bus number 1 and 2. So total generation is what? It is nothing but PG1 plus PG2. Total demand is what? It is PD1 plus PD2. The main objective of economic load dispatch is to minimize the fuel cost. So minimizing the fuel cost is the objective function. Okay. And what about, you know, the equality, what about the power balance equation? Equality constraint is what? Generation equal to demand. Okay, subjected to H of Pj equal to Pd minus Pga. And then using Lagrangian multiplier, we have to form the equation, cost equation. C conjugate is nothing but C plus H into lambda. And then you have to differentiate for the objective function is to minimize the fuel cost. So you have to form the equation. So it is C star equal to C of Pj plus lambda into, and you know the power balance equation, it is Pd minus Pga. So differentiate this equation with respect to Pga and then equate to 0. You're getting as incremental cost function is nothing but what? It is after differentiating, you're getting this equation lambda equal to dou Ci divided by dou Pga. So this is the formula for coordination equation with loss. Thank you. In next video, we will discuss about lambda iteration method to find a solution for economic load dispatch. Thank you.